This screencast is going to explain to you the exponent properties that we're going to be covering in this next unit. So first, some basic terminology that many of you probably already know. The exponent would be the top number that's raised a little bit, and the base is the bottom number. The exponent is going to tell you how many times you multiply the base number together. So since it's x to the 5th power, means you are multiplying 5 x's together. And y to the 3rd power means that you take the y, the base number, and multiply it times itself 3 times. Now, knowing that, what we can do is multiply exponents as long as they have the same base. And now, let me write this out, and I would encourage you, until you get the hang of this, to write out all your problems. So 2 to the 3rd power, since the exponent is 3, I'm going to take that 2 base, and I'm going to multiply it by itself 3 times. Then I'm going to multiply times the 2nd term, so I'm going to take 2 times itself 5 times. So 1, 2, 3, 4, 5. Altogether, I am multiplying 8 2's together. So it's 2 to the 8th power. And if you were to work this out, I believe it comes out to be 256. Now we can do the same thing with the exponents, or the variables. X to the 3rd power means you take x times x times x, 3 x's, times 4 x's, 3, 4. So x to the 3rd takes those 3 x's, x to the 4th takes the other. Altogether, I have 7 x's. So the answer to this problem would be x to the 7th power. Now I'm going to see if you can do these two problems from what we've done so far. All right, the next thing we're going to work on is raising a power to a power. This is a very important property, and I want you to make sure that you write all of these problems out. Take out paper if you haven't done this. Now, in this problem, this first example, we have got 2 exponents, one inside the parenthesis, one outside. We're going to start with that one on the outside. And so since that's a 3 and it's outside the parenthesis, that means that you take 5 to the 2nd power times 5 to the 2nd power times 5 to the 2nd power. So you're taking that inside term and multiplying it by itself 3 times. Now, from what we've done before on the last 2 slides, you know that 5 to the 2nd times 5 to the 2nd times 5 to the 2nd is like having a 5 times 5, and then another 5 times 5, and then another 5 times 5. So altogether, this is going to be 5 to the 6th power because we have 6 5's that we're actually multiplying together. With variables, you're going to do the same thing. You take the outside exponent 4 and you apply it to what's inside the parenthesis. So this would be x to the 2nd power multiplied by itself 4 times. And then you can break each of these down into an x times x. which altogether will be x, and there are 8 of the x's altogether, so it's x to the 8th power. Now, make sure you write these two out, but I want you to try exactly the same thing as we just got done doing and see if you can get the right answer. Okay, the last thing we're going to be working on is the division property. And over here you can see that I have got x to the 5th power divided by x to the 3rd. Now I wrote out all the x's in the numerator and the x's in the denominator. And what you can do now is for every x that's in the numerator, you can cancel out one in the denominator. So we're just going to go through, we're taking those and xing that pair out. We'll x out that other pair. We'll reduce out the other pair. And once I've got the 3 on the top reduced with the 3 on the bottom, that gives you x times x, which is x to the 2nd power, would be the answer to this problem. And the last one we've got a fraction raised to the power, and it's not as hard as you might think it looks. What you're going to do is you'll take the exponent of a 4 that's outside the parentheses, and you're going to apply it to both the numerator and the denominator. So we've really got x to the 2nd raised to the 4th power over y to the 3rd raised to the 4th power, which is equal to, we'll do each part separately. Since this outermost exponent is a 4, we're going to write x to the 2nd power, and we'll do that 4 times. X to the 2nd times x to the 2nd times x to the 2nd. And in the denominator, we're going to write y to the 3rd power 4 times. So y to the 3rd times y to the 3rd times y to the 3rd power. Okay, and again, we could write all these x's out on the numerator if we wanted to, but I think maybe you've seen a pattern now, or you can do it without writing them all out. There are 2 x's in each of these terms up here. So 2, 4, 6, 8, we have x to the 8th power, and in the denominator, we have 3, 6, 9, 12 y's, so y to the 12th. Now we can't reduce out anything in the numerator and denominator because they are not the same variables. There's an x in the numerator and a y in the denominator. So this is the final answer. So let's see how well you can do with these 2 division problems.